Okay, so we're going to solve a system of equations by elimination. And remember, with elimination, the way this works is we're going to add these two equations together term by term, and either the x's or y's should be eliminated, leaving us with one variable, and then we can solve the equation. So the problem here is that if I add 8x and 2x, that doesn't add up to 0. And if I add negative 7y and negative 14y, that doesn't add up to 0. So as it stands now, if I add these equations, nothing will be eliminated. So I need to change one of the equations, or both of the equations, in this case 1, by multiplying all the terms by some factor, some number, that will create a situation where these would add up to 0. So for example, the y's here, look at our y's. We have negative 14y and we have negative 7y. So if this negative 7y was instead 14y, then these would add up to 0. So I'm just going to multiply this equation, every term, by whatever number would make that into a positive 14y. That number is negative 2. So I'm going to take negative 2 times 8x, negative 2 times negative 7y, and negative 2 times 9. So this new equation I get is negative 16x and positive 14y, and that equals negative 18. So I'm not going to use this equation anymore. I'm going to use this new equation. Now, this equation and this equation are equivalent equations, so I can use this instead of this in my system, the difference being that here, so I'm going to use these two equations now. And so when I add these equations together, 2x and negative 16x is negative 14x. And negative 14y plus 14y, there's 0, which is what I wanted. Now notice I only have one variable, so now I can solve this equation for x. And negative 10 and negative 18 add up to negative 28. So I have negative 14x equals negative 28. Very easy to finish solving this. Just divide by negative 14 on both sides. So I get x equals to 2. And then to finish, it's just like substitution. So just like when we solve by substitution. So I'll take either one of my equations. In this case, I'll take 2x minus 14y equals negative 10. And I'm going to make this substitution. I'm going to substitute in the 2 for x. So 2 times 2 is 4. And so again, notice after that substitution, again, I only have one variable, so I can solve for that variable using just these steps we're very familiar with now. Right, this is 0, so I have negative 14y equals negative 14. Oops, don't forget your y. And then divide by negative 14. So y is positive 1. So my solution to this system is the point 2, 1. So again, just quickly to review, right, I want to solve these by elimination, meaning I want to add the two equations together and get one of these pairs of variables to cancel out because they're additive inverses, so get them to add up to 0. It's not the case here. They're not going to add up to 0. So instead I change one of the equations by multiplying every single term. Don't forget to multiply every term. Sometimes people just multiply one side or the one term that they want to multiply. You got to multiply everything so that it's an equivalent equation. So 8x times negative 2 and negative 7y times negative 2, that makes that 14 that will cancel with this negative 14y. Great. Let's do one more example, just in case you need to see it one more time. So again here, I have a system of equations, two equations. I'm going to try to solve by elimination, meaning I want to add the two equations together term by term to create a new equation that only has one variable. Now right now, 10x and negative x would be 9x. 10y and negative 6y would add up to 4y. So nothing would be eliminated. So again, I have to change one of the equations. So let's just choose, doesn't matter which one you make into additive inverses, the x's or the y's. We'll just pick x this time. So here's 10x. So if I made this to be negative 10x, right, they would cancel. They would be additive inverses. So I'm just going to multiply this whole equation by whatever number would give me the number that I want here. So I want it to be negative 10x to cancel this 10x. So I'm just going to multiply by 10. So I'm going to multiply this by 10, multiply this by 10, and multiply this by 10. So I'm going to rewrite both equations. So my original equation is 10x plus 10y equals 0. That's this guy. And now this equation that I'm changing becomes negative x times 10 is negative 10x. And negative 6y times 10 is negative 60y. And 25 times 10 is 250. So now if I add those two equations together, right, 10x and negative 10x, there we go. There's the elimination. So they add up to 0. And then this is negative 50y equals 250. So I have this very simple one-step equation to solve for my y value. So I just divide by negative 50 on both sides, and y equals negative 5. And as we know, that's the y-coordinate of my solution to this system, right, where they would cross if we graphed them. And so then I just choose any equation. I'll pick this first equation. Doesn't matter which one, right? It's the solution, so it should work in either equation. And then I make that substitution. Make sure you make it in the right place. We solved for y here, so we got to plug it in for y. So now I have 10x plus 10 times whatever that y value is. So that's 10x minus 50 equals 0. Just solve for x. We'll add 50 on both sides. Now I have 10x, right? That's 0. Equals 50. Divide by 5. Oops, divide by 10. What am I saying? Divide by 10. How did that happen? Close call. Close call. Divide by 10. So x equals 5. So my solution is the coordinate 5, negative 5. So we're showing solving a system of equations by elimination. Notice at the beginning it was not going to eliminate either x or y. So we multiplied each term in this equation to change this negative x into negative 10x, which would cancel with that 10x. Great, there you go. Solving by elimination, where we changed one equation.